All right, so this is absolute value equations, the beginning of the Math 3 units. And first of all, the first thing we have here is what is the definition of absolute value, and that is the distance away from something. So if you want to know the absolute value of something, you're always going to find it's going to be a positive because we're finding how far away you are. You may be 3 below or 3 above, but the absolute value is still going to be 3. And there are 3 types of absolute value graphs that you want to see here. If it never crosses, so the x-axis is down here, this is the horizontal or the x-axis. If it never crosses the x-axis, then your answer is that there is no solution because it is never crossed. If it only hits the x-axis one time, so like here it hits it right at 2, then your answer would be that there is one solution. And then if it crosses the x-axis twice, like that one crosses at -2 and +4, then that would be 2 solutions. So there's 3 possibilities. You can have no solution, 1 solution, or 2. And if you solve a absolute value equation by hand, if the absolute value of x equals 5, we would basically just split that up and say the answer is -5 and +5. Because if you put -5 in there and take the absolute value of it, it gives you +5. If you put +5 in there and take the absolute value of it, it also would give you +5. So on the next thing, let's go to your next examples. If we want to just look at the regular equations first. So if you'll just look at the left side of this screen and kind of fill that in. In a regular equation, you have 5x plus 9 equals 144. So step 1 of this, what would be a 2-step equation, step 1 is to subtract 9. So then you're going to have 5x is equal to 135 because we've subtracted 9. And then you're going to divide by 5, which gives you x equals 27. That's a regular equation. If you look at our second one, step 1 would be to add the 3. It's further away, so we want to add the 3 to the right side. That gives us x over 7 equals 4. And then step 2 would be to multiply by 7 to get rid of that from the bottom. So now we have x is equal to 28. We go to question number 3. We have a minus 11 out here, so we want to add 11 to the right side. So we get 2/3 x equals 8. And then if you want to get rid of the 2/3, then you've got to multiply by 3/2, the opposite of it. So 8 times 3/2 gives us x equals 12. And then our last equation here is at the bottom. 4x minus 5 equals 27. 4x minus 5 over 3 equals 9. The first thing you would want to do is get the 3 off of the bottom of the fraction. So you're going to multiply by 3. And that gives us 4x minus 5 equals 27. Our second step would then be to add 5. So now we have 4x equals 32 right here. And then our third step would be to divide by 4. So you end up with x equals 8. So those are regular equations. So I just want to take you back to equations you've seen in Math 1 and Math 2. Now we want to kind of transfer that to an absolute value equation. So in this one, to set up an absolute value equation, again, it's very similar as what we were talking about. So the first thing you would do is you would look out. You see the absolute value bars here. You would look outside of the absolute value bars and you would subtract 9. And that gives us 5. And the absolute value of 3x minus 6 equals 135. And then, just like we would in a regular equation, we would divide by 5. What happens is we have isolated the absolute value. So what that means is on the left side of the equation, all we have is the absolute value bars. We have the absolute value of 3x minus 6. And then on the right side, we have equal to 27. At that point, we'll split them up into two equations and solve. And we're going to do that in just a little bit. In question number 2, we would add 3 because it's further away. That will give us 4. Then we would multiply by 7. And now we have the absolute value bars by themselves, which is the absolute value of 12x minus 8 is equal to 28. We would then split them up and solve. So the goal here is we're trying to get absolute value by itself. That means it's the only thing on the left side of the equation. And then we're going to go through how you solve one in just a minute. Number 3, we would add 11 here. So you get 2/3, and then the absolute value of 2x minus 10 is equal to 8. And then we would then multiply by the opposite of 2/3, which is 3/2. And so that gives us the absolute value by itself. Just the absolute value of 2x minus 10 is equal to 12. We would then split that up and get our two answers. And then finally, in number 4, we would multiply by 3 because it's on the bottom. So everything's above that 3. So we multiply by 3, and that gives us 27 on the right side. Then we would add 5. That gives us 32. Then we would divide by 4. That gives us 8. So we have the absolute value of 8x minus 16 equals 8. If you notice, what we're trying to show here is the goal is to isolate the absolute value bars. That means that's the only thing we want. Anything that's outside of the absolute value bars has to be moved to the other side of the equation. So let's look at example number 1. And you don't have to do the check over here, but we do want to look at this part on the left. So in example 1, we have the absolute value of 2x plus 6 minus 3 equals 13. So you notice the minus 3 is on the outside of the absolute value bars. So the first thing we would like to do here is add 3 to the right side. So we will get the absolute value of 2x plus 6 is equal to 16. At that point, we have done step 1, which says to isolate the absolute value. We never distribute a number into the absolute value. What's in the absolute value bars always stays there. So now we move to step 2, which is split the equation into 2. One positive and one negative. And what that means is what it's equal to, one is going to be positive, one's going to be negative. So 2x plus 6 equals 16. So that's just basically writing it down without the absolute value bars. 2x plus 6 equals 16. And then our other equation is 2x plus 6 equals negative 16. So the only thing that's changed is what it's equal to, 16 and negative 16. And now we're just going to solve it because the absolute value bars are gone. We can just solve it out. So 2x plus 6 equals 16. We would subtract 6. You get 2x equals 10. Then we would divide by 2. And x equals 5. That's our first answer. Our second answer, 2x plus 6 equals negative 16. We would subtract 6 and get negative 22. So 2x equals negative 22. Then we would divide by 2 and get x equals negative 11. So now we've come up with our second answer. So our answers are 5 and negative 11. Okay? Now, let's go to example 2. In example 2, we have two things outside of the absolute value bars. So we write it down. 4, absolute value of 5x minus 10 plus 23 equals 3. Step 1 is going to be take that plus 23 and move it to the right side. So we subtract 23, and we now have 4 absolute value of 5x minus 10 equals negative 20. We still want to get the absolute value by itself, so we're going to divide by 4. And now we have the absolute value by itself. But it's the absolute value of 5x minus 10 equals negative 5. Well, there's something we talked about earlier. No matter what number I put in here for x, anytime we put a number in for x, whether it's a positive or a negative, when you take the absolute value of it it's always going to equal a positive. So this is telling us that the absolute value would equal -5. That's not possible. So when you've isolated the absolute value by itself, like we did in number 1 and like we've done here in number 2, it must be equal to a positive number, right? Not your two answers, but the absolute value must be equal to a positive, like it was in number 1. Here we have the absolute value equal to a negative. It's equal to -5. So that means automatically there is no solution. Now, if you actually went and worked it out, you would get two answers, but those answers are incorrect. So just know, if you've started the problem and you isolate absolute value, you get it by itself, and you have the absolute value equal to a negative number, then you have no solution. So we're going to move to our last ones. Example 3 says the absolute value of x plus 5 equals 3x minus 7. In this case, the absolute value is already by itself. Okay, so you don't have to isolate it because it's already there. So you say x plus 5 equals 3x minus 7, and you say x plus 5 equals the opposite of that, the negative. So negative 3x plus 7. And then you want to solve both of those out and get your answers. Over here, you're going to do the same thing. It says 2x minus 3, the absolute value of 2x minus 3, it's already there, equals 3x minus 2. So you're just going to drop the absolute value bars and say 2x minus 3 equals 3x minus 2. And then the opposite, 2x minus 3 equals negative 3x plus 2. And then you will solve those two out. Okay, and that takes care of your notes for section 1. And then hopefully what we'll be able to do once you've taken those notes and once you've gone through those problems, then you should be able to solve an absolute value equation. And then tomorrow we will take you to solving, and we'll be working on a worksheet for absolute value equations. All right, thanks.